What is differentiation? Differentiation can be defined as a derivative of a function with respect to an independent variable. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. Differentiation was applied when determining the increasing or decreasing of a function. It is also used when determining the speed or distance of moving objects. Other than that, based on our topic, the derivative was used to find the maximum or minimum values of a particular function. In apply of differentiation, we have 5 subtopics, which is related with analysis of functions 1 and 2, apply maximum and minimum problems, and the last one is Rolle's theorem and mean value. What is applying maximum and minimum problem? In a process of finding maximum or minimum values is called optimization. For example, maximize the profit in a company or minimize the cost or find the at least amount of material to make a particular object. To solve apply maximum and minimum problem is to find the derivative and then let the derivative equal to 0 and find the values of the variable. The last one is to do the second derivative test. If second derivative test is above 0, it's a minimum value. And if the second derivative test is below 0, it's gonna be maximum value.
Question 1. Show that the combine of fish pond and the flower border is A equal to 4x plus 360 of x plus 84. Question 2. What's the dimension of the fish pond will minimize the combined area? Question 3. What is minimum combined area? A rectangular fish pond with an area of 60 meters square is surrounded by a flower border with 3 meters wide on two sides and 2 meters wide on the other side, as shown in figure above. Let x and y be the length and width of the fish pond respectively.
So the question says, a rectangular fish pond with an area of 60 meters square is surrounded by a flower border with a 3 meter wide. So this is a 3 meter wide and 2 meter. We know that the fish pond area is 60 meter square. The formula for rectangular area is length multiply with width. So the length is x multiplied with y. So this is the area for the fish pond. And we know that the fish pond area is already 60. So basically it's 60 meters square equals to xy. So 60 equals to xy. Basically the combined area is the whole rectangle. This length is x. And then this one is 3 meter. This one is 3 meter. So we know that the total length is 3 plus x plus 3 equals to x plus 6. This is the length. And the width, this side is 2 meter. This one is y. And this one is 2 meter. So the total is 2 plus y plus 2 equals to y plus 4. So we already have the width and also the length. Now we're going to get the area y plus 4 and then this is x plus 6. So the combined area equals to, now we just multiply. So we got xy plus 4x plus 6y. So we have to substitute the y variable. Now we use the 60 equals to xy. We let y equals to 60 over x. We're going to substitute in this equation. Then we just simplify. Then just simplify again. So this is the answer. So basically it is shown. What we need to do is we're going to differentiate the combined area. So the equation for combined area is A equal to 4x plus 360 over x plus 84. We're going to do A x plus 300x to the power of -1 plus 84. Differentiate A over dx equals to 4 plus -1 multiplied by 360 x to the power -1 minus 1 plus 0. Then we're going to get -360 x -2. I'm going to simplify x2. In order to get the value of x, we're going to let the dA over dx to 0. So 4 minus 360 over x squared equals to 0. -4 times x squared, then -360 over -4 equals to x squared. Then we're going to get x squared equals to 90. We get x equals to square root 90. Answer will be plus minus 9.487. In order to determine whether this is the maximum or minimum value, we have to do the second derivative. So it's d squared a over dx squared equals to 0 minus -2 multiplied by 360 x to the power of -2 minus 120 x -3. Then it's going to be like this, 2 over x to the power of 3. We are going to substitute the x value into this second derivative. To the power, get 0.843. So 0.843 is more than 0, which means that this value is a minimum value. So the minimum value for x is 9.487, but we still didn't get the minimum value for y. Okay, in order to get the value of y, we're going to substitute the x value in this fish pond area formula. So y equals to 60 over 9.487. We're going to get y equals to 6.324. Okay, so the answer will be the x is 9.487 meter and y is 6.324 meter. In question C, they want minimum combined area, which means that the x and y value must be the minimum value. Then we'll just substitute the x value into the formula. So we're going to get A equals to 4 multiplied with 9.487 plus 360 over 9.487 plus 84. And the answer, we will get 159.895 meter square.
To conclude, applied maximum and minimum problems closely related to the concept of application of differentiation. The most crucial part is when analyzing the problem after finish accumulated the information. Next, find a derivative and let the derivatives equal to 0 to find the value of variable. Then, use the second derivative to phantom out whether it's maximum or minimum value. If the second derivative is less than 0, then it's a maximum value. But if the second derivative is more than 0, then it is minimum value. Lastly, substitute the value in the equation. This method is exceptionally useful and beneficial in dealing with business or other difficulty which need calculation in our daily life.